Let's talk about some flat Earth logic, plus a couple of moon pics. Wanted to remind everyone that the goal and my intent for my channel is strictly to add value to the flat Earth community. So that means I have absolutely no desire to debate flat Earth with anyone. I really just want to help empower those new to the flat Earth community, and even if you're not new, I really only post videos I think add value that I haven't really come across that I would like to get some more ideas out there. So let's talk about some flat Earth logic that I think you will like. So number one, the number one flat Earth skeptic argument is actually the most irrelevant. Okay, I wanted to help you understand this. That way you can have conversations with people. I love what Mark Sargent says about talking about flat Earth to people. He says the number one rule of Flat Club is you do not talk about Flat Club, and I love that. He says you have to approach people from the side, kind of sneak it in there, like, hey, I saw this crazy YouTube video. Somebody actually said the Earth is flat. So funny. But you should seriously watch it and look at it, and then you stare at them. But if you'll go back and remember the first time you really ever heard about flat Earth, you'll probably remember coming up with a bunch of these right here. Well, how do you explain? I mean, this is me, right? I heard this and I'm like, wow, I'm looking at all this evidence these people are saying, putting on YouTube, and I'm like, well, how do you explain satellites? And how do you explain the Coriolis effect? And how do you explain, the pendulum? And how do you explain? And well, what about NASA? And on and on and on. And if you have ever had any experience talking to people about flat Earth or trying to bring the topic up, this is the first thing that people throw out there. And the reason is, it's because you have disrupted one of the most fundamental things in their paradigm and how they view the world. And so when you're trying to change somebody's worldview on something, their paradigm, it just, this is something that's been there since day one. It was in kindergarten class when you had the globe in the classroom, and you're now telling them that no, that's not right. The initial reaction is just no way. There's no way, and they try to just argue with you and refute you, and they come up with this question right here. As I said, this is the number one skeptic argument. Okay, if somebody's literally going to argue with you, and you can look at comments in Facebook and things like that, which is why I really don't care to argue with anybody, YouTube, Facebook and YouTube. You can look at the comments. I don't really care to argue with anybody, because most of them are actually this argument right here, the skeptic argument, and it's actually the most irrelevant argument, and that is, how do you explain it? And so why is that the most irrelevant argument? It's because they are, well, let me skip to this slide, and then I'll explain why it's the most irrelevant. Here's the only two relevant things when we're talking about flat Earth. Okay, number one, amateur video and amateur photography. Okay, because we've already called into question, any type of official space program. We've already seen, if you look at all kinds of other videos, you'll see there's a big reason to be skeptical from all of that. So amateur video and amateur photography are definitely relevant. And also observable evidence, things we can observe, and the scientific method. So now when you go back to this argument, when they say, well, how do you explain this? How do you explain this? How do you explain this? What they're really asking you for is, I have this worldview and you just disrupted it. Science, quote unquote, popular science tells me all these things. And so now you tell them, no, the Earth is a different shape than you thought it was. Now in their mind, they're having to find answers to explain all of this stuff. And they think that's somehow debunking flat Earth, and it's not. Okay, what you have to establish first, and I should have added this slide in with another with another phrase here so you could visually see it. But what you have to establish first is that the Earth is round, or that the Earth is flat. Or I shouldn't say flat because there's several theories, but it's not round, right? Is it round or is it not round? Is it a globe or is it not a globe? Okay. Once you establish that, then you have to start explaining, what about satellites? What about GPS? What about the plane patterns? What about? Okay. All of those, well, how do you explain questions? Can't prove anything. You see, if you assume the Earth is a globe, then you can explain, planes and GPS and satellites and NASA and all of that. But if you assume the Earth is flat or some other shape than a globe, you can still explain planes and GPS and NASA and satellites and all of these things. They're just going to be different explanations, right? So the explanations don't prove the shape of the Earth. You have to establish the good evidence for the shape of the Earth. You have to establish, you have to establish the shape of the Earth before you start talking about how to explain, right? And that's the point I wanted to make, so that you understand when you're talking with people that all of those explain questions are simply them trying to rationalize their paradigm. Okay. So now when we get to this observable evidence here and the scientific method, this is what I mean by that. These two things right here. Okay, I have a math degree. I spent 4 years teaching calculus. While I was working on my master's in math, I actually stopped the education system. I got out because it was just too rigged. There was too much government involvement, and I decided to be a doctor instead. And that way I could help people in my own way. But nonetheless, I know a thing or two about math. And what I want you to realize, I don't know if you've ever heard anybody say this before, but this may be new to you. And if it is, and if your initial reaction is like, yes, it does, then you need to really consider this. Mathematical models prove nothing, ever. Never, never, never. Mathematical models never prove anything, right? They prove nothing. Prove, that's the word here, prove. Okay? Mathematical models serve a great purpose, and that is if your assumptions about the way the world works are true, then you can use the discoveries in mathematics to illustrate and to help you understand. But if your initial assumption is wrong, then your mathematical models are therefore wrong, no matter how pretty they may look. Okay, and there's other videos on YouTube that really go into that. I know Globebusters have done one recently. Phenomenal job talking about modern physics and how it's basically in modern astronomy, and how it's basically all built on mathematical models and not actual observable evidence, right? And the scientific method. So go check some of those videos out to learn more about that. But just understand, mathematical models don't prove anything. You can't prove anything with math. Okay, it just helps you to understand the world around you. But your assumptions about the world around you and how it works have to be true in order for the mathematical model to be valid and relevant. And also this right here, science doesn't reach conclusions, scientists do. When you're using the scientific method, and this is a massive flaw that we have, especially in healthcare today, and the studies that are funded by the drug companies or the vaccine companies or anybody with a financial interest in how the study turns out, is that science and the scientific method, when done properly, don't give you any conclusions. They just give you data. They just give you information. It's up to the scientist to determine and decide what conclusion should be reached from that data. And a lot of those conclusions, okay, a lot of those conclusions are based on your initial assumption about how the world works. Okay? So if you assume that a big bang that came from nothing generated everything and we've evolved over millions of years, and you start studying humans, their behavior, and their health, you're going to arrive at a much different conclusion with that data, as if you come from the initial assumption that there is some type of intelligent designer that put everything in motion, and that you have a purpose, and that you were placed here for a purpose, and everything has a design. That's just one example. So math doesn't prove anything. Scientists reach conclusions. Science does not reach conclusions. All right, really quick recap and then a moon picture. All right. Number one, flat earth skeptic argument is actually the most irrelevant, because this is mainly just a visceral reaction people have when they first hear about flat earth. So when you're discussing it, realize they're just trying to remodel their entire worldview. Think about it from the perspective of you when you first were there. And all of these how do you explain questions are irrelevant until you actually establish what is the shape of the earth. Then you can start explaining. And to determine the shape of the earth, the only thing that is relevant is amateur video and photo, okay? Amateur footage, and things that you can observe yourself with the eye, with your own eyes, and test yourself. Also known as a scientific method, which is going to give you data, and it's up to us to determine the conclusions. Science doesn't reach conclusions, scientists do. And remember, you can't prove anything from mathematical models. All right. Keeping this under 15 minutes. I came across this interesting photo. Someone had posted this, a flat earther had posted this on Facebook. It says, if the moon is up in space, how am I able to see blue sky through it? Shouldn't it look more like this? I haven't really taken an hour to really process this photo, whether I agree with this logic or not. From the heliocentric point of view, I would think someone would come back with this saying, well, it's not that you can see through it, it's just that there's not enough light on that half of the moon to make it through the atmosphere. Yeah, that's what I think somebody would say. But if you've watched videos from people like Crow777 and others, I think a flat earth explanation for this would go something more like, the reason you see it appear like this is the fact that the moon generates its own light. From my research, that's really what I think. I think there's a lot of good evidence for that the moon actually generates its own light. And the reason you don't see anything over here, like during the daytime, is because there literally is nothing there to see, because there's no light coming from this. It's generating its own light. So that's what I think the flat earth explanation would be. And I actually took this photo about a week ago, I believe. This is a picture of the moon in the daytime, and I color inverted it. I just inverted the colors, but I want you to look at how it turned out. I mean, literally down here, as it's coming around, it just stops. I mean, all of this over here, this brown color, this tan color, is the same as over on this side. I mean, it's not even like you can just barely see a shadow, or it's slightly discolored so that, you know, the rest of the moon is there. Oh, hold on, my video is going out. Okay, okay, sorry for the technical difficulties. We're back, or I'm back. Basically, I just wanted you to see how interesting this was, that when I color inverted it, it looks as almost it's just dissolving away. Just dissolving away. Not even not even like it's reflecting any light, like it's just dissolving away. All right, hope you enjoyed.